Okay, so today, all right, we're going to continue talking about data and ways to represent it and ways to read it. All right, so just a reminder of where we've been so far. We started with the data distribution, so it's ways to look at data. We looked at different bar graphs, we looked at pie charts, we looked at things of that nature, okay? And from there we went on, okay? So we've done mean, median, and mode. We've done stem and leaf plots, right? Just all different ways to look at data and develop it from there. All right, now we're going to another way to look at data, okay? And it is with a box and whisker, okay? So a box and whisker plot. Now, this is going to deal with some of the stuff that we've talked about, and it's just another way to look at it, all right? So this is one of the easiest things because to create a box and whisker plot, you only need 5 numbers, okay? And guess what? Other than putting them in order, you don't have to do any math. So all that stuff we did yesterday with the mean that you felt like took forever, where you had to add it all up, you had to go through it and do it of that nature, you don't have to do that here. So this is typically one of students' favorite things to do here. All right, now we do have some definitions to get through before we get there. The first one are measures of central tendency. So this is something that we've actually been doing. This describes how data clusters around one value, aka what we did yesterday, the mean, the median, and the mode. So remember the mean, okay, is the average. The median is the number that is in the middle when the numbers are put in order. And then the mode is the number that shows up the most. Okay? The next thing to look at is called the spread. All right? The spread is how the data values are spread out from the center. Okay? So that is your range. So remember we found out yesterday the range is the highest number minus the lowest number. Okay? Your quartiles, remember we talked about upper quartile and lower quartile. Your Q3 and your Q1, that's going to be used today. The interquartile range, which we also talked about yesterday, and we're going to talk about again here. But remember, your interquartile range is just Q3 minus Q1. And then something called the mean absolute deviation, which we're going to work on the next 2 days. Okay? Or excuse me, that's going to be Thursday and Friday. Okay, now let's talk about this because this is some stuff that you're going to have to use today. We talked about it yesterday, so it is a nice little refresher reminder, something for you to see and understand. The first one is your first quartile, okay? Your first quartile, okay, is your Q1. It is the median of the lower half. So you split it with the median, then if you looked at just that first half, that would be your Q1. Okay, do you need to see a picture? Okay, so I showed you one yesterday. So remember, it would be something like this. Say those are your numbers, okay? This would be your median, okay? Well, Q1 would be the halfway point of the lower half, okay? That is what the first quartile is, your Q1. The third quartile, your Q3, would be just the same thing, but in the upper part. So if you had a list of numbers, I'm just drawing a line for now, and the median splits it in half, okay? Well, the opposite of Q1, your third quartile, Q3, would be in the middle of the upper half, okay? So they're going to be the number that are between them. And just like yesterday we learned, if it is odd numbers of things up there, then it's the one in the middle. If it is even, it's between the two numbers. You got to find the number between them. You got to take their average. Okay? And then the interquartile range down here, okay? Just remember the IQR, that is the difference between the third and the first quartile. So remember, we said yesterday that the IQR is equal to Q3 minus Q1. All right, and we did a couple problems like that on our notes. There was none on your homework yesterday, but that was all in the notes and stuff like that. Okay, so are we good so far looking at that kind of stuff? Okay, that's all definitions you've heard. We've touched on them and gone. Now we get to the new stuff, the fun stuff. Okay, this is an example of a box and whisker. Okay, this is an example of a box and whisker chart. So notice some things to notice. You've got several points up here, and I'm going to talk about what each one of those are. But then at the bottom, you've got what? a number line. So it's a way to represent the data. Okay, now I'll show you as we get into these and have to draw some of ours how we're going to do it. I'm going to make it a little bit easier on you, but just doing this, it's a good way to look at it and see and get some of this information. If I ask you to create one, I'm not going to make you be as detailed down here, but you're going to have to tell me what some certain numbers are. You got me? Okay, so now let's go through and talk about the 5 numbers that you need to create a box and whisker chart. I'm going to start with what, in my opinion, are the easiest numbers. Those are the edges of the box and whisker chart, or box and whisker plot, which are these hashes at the end. Okay, everybody see those? All right. The one on the left is simply this. It is the lowest number. So when you're going to look at your data, the point that goes to the left, that is going to be your left whisker, okay, is going to be your lowest number from the data. So what do you think the right whisker is going to be? The highest number, or the largest number. That is correct. Again, this is just going to be given to you. They're going to give you a list of numbers, much like we did yesterday, and you're going to have to create them and look at them. Okay? Now, the box part is where you're going to look at quartiles, okay? So, the line that is in the middle of your box, and it's not necessarily in the middle, it is the line that is always in your box. Sometimes it's towards one end, sometimes it's towards the other, sometimes it is perfectly right there in the middle. That line is represented by your median. That is correct. So, that tells you right now, just by looking at this stuff, you're going to be given data, and just like we had to yesterday, you've got to put the data in order. So you're going to have to list the numbers from smallest to biggest. Okay? Now, based off of what you've seen so far, does anybody have any guesses what the first box and the last box are going to be? What did we just look at as a definition? The first quartile and the third quartile. That is 100% correct. So the start of your box is going to be your Q1 value. And then the end of your box is going to be your Q3 value. Okay? So those are the 5 numbers that you're going to need to be able to create a box and whisker. Are there questions for that? You sure? Feeling good? All right, so here is what I'm going to tell you, and I'm just going to show you from this. If I ever ask you to create your own box and whisker, I really care the most about you just putting what value is there at the bottom. Does that make sense? I don't care if you space it out and do tallies and all like this, but like if this lowest number was 12, just write a 12 down there, okay? And then like this might be a 22. This might be a 31. This might be a 45. And then this up here is 50, okay? I care more about those numbers than you creating some kind of fancy number line, all right? Now, some fun facts, okay, about these boxes. Do you think all of your boxes are going to be this big and evenly spaced? No. It's going to depend, okay? When you have a big box in your box and whisker chart, your data is typically more spread out. That means your numbers are wider, there's not as many repeats, they're not as tight together, okay? If you have a shorter box, your data is more on top of each other. So do you remember the second example we did from your homework with all those decimals that were right around each other? That would be an example if you did a box and whisker of where the box is super small and it's more compact and put together. Y'all with me? And then just the ends, it really just depends, okay? Because the lowest and highest numbers, you could have some outliers. Do y'all know what outliers are? Yeah, they're just numbers that don't go with it. So that could affect it. If you just got some random outlier, it might make your highest number be super wide out there and everything else is further away. All of that just kind of depends and goes. All right? So let's come through here and do this together. We have to create one on your notes. I'm making you create it here. All right? So, look in here. We've got these numbers. All right? What we need to do is put them in order. Okay? So, let's do that together. What's the smallest number y'all see? I see 3. Okay, so 3 is my smallest number. Okay, is there a 4? Yeah. Are there any more 4s? No. So we're good there. What's next? Are there 5s? Yeah. How many are there? I see 2. Okay. Are there any 6s? Yep. 2? Perfect. Okay. Is there a 7? Yeah. There's 1 7. Okay. It was between the 2 6s up top. Is there an 8? Yeah. There's an 8. Okay. I see a 9. Okay. 1, 2, 3 10s. Okay. Is there an 11? Yeah. How many? 2. Y'all see how important this is. You got to look and make sure you get every number. Okay. I see 2 12s. Agreed? 2 12s. I see a 13. Okay. I don't see a 14 though. I do see a 15. And then the last one is a 20. Woo! Now, we went through that a little bit faster, right? I can feel I'm losing some of you. So that's why I'm going through it faster. I've worked with this for 20 plus years. You all understand what I'm saying? So you might not go as fast. That's why tonight when you see your homework, I'm not going to give you a bunch of it. Okay? But that means you got to take your time and get good quality effort and kind of reps with it. All right? Now, using this, they ask us to create a box and whisker chart for the softball's 19 games that they've played. All right, so this is the number of runs scored by that softball team. All right, well, what's probably the easiest thing for us to do if we're creating a box and whisker? Put the 20 at the end and put the 3 at the beginning. That is 100% correct. So as I look at this, the easiest thing for me to find are the lowest number and the highest number. Okay, so I know what they're represented as. So I'm going to put a dash and a dash. And then here's all I need from you. Okay, well, hey, what was that lowest number?
3.
3, I'm going to put it down here. That highest number was a 20. Perfect. So right now I'm good. As a teacher, as your teacher, if you can do this, I'm good so far. Okay? Now, the next thing we want to find is the median, because you got to have the median before you can do anything else. Well, we know how many games are in there. 19. We don't even have to count this time because they told us up here that there were 19 games that we were looking at. So, as we come down here and try and find it, the number that's going to split it is when there are 9 on one side and 9 on the other. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. So it should be this number 10. Let me just make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, that number 10 is where it splits. Okay? Now, here's something that I am going to ask of you to do. Let's make this box look semi-realistic, right? If I'm choosing the number 10, is it going to be closer to 3 or closer to 20? It's going to be a little bit closer to 3 because there's less space between it. So I don't want to split it evenly. I'm going to split it just a hair over here on the left side. And I know that that is my median, and that is represented by the number 10. Well, now I've got to go through here and figure out what my Q1 and my Q3 are. Well, I know that there are 9 on each side, right? So to find Q1, I need to find where it splits the first quartile, okay? Which is this over here. Well, there's 9 numbers, so 1, 2, 3, 4. 1, 2, 3, 4. It's going to be that number 6. Okay? So, my Q1 is going to be the number 6. All right? Well, that's going to be probably roughly in the middle. So, I'm going to go right here and label that Q1. But hey, that was the number 6. And then I'm going to do the same thing for the other side. Now I got to look at my upper quartile. 1, 2, 3, 4. 1, 2, 3, 4. So the number that splits it is what? 12. Now, this is where it's got to be big. I need you to understand how this is going to look. All right? 12 is really close to 10. It's a lot closer to 10 than it is to 20, right? So that line's not going to be very far off. And that's going to be 12, which is my Q3. Okay? And then all you've got to do is create your box from Q1 to Q3. And then you want to just connect the whiskers out to your highest and lowest. That is a representation of a box that you can tell, okay, is shifted a little bit. It's not exactly in the center. You got 20 pretty far out there and 3. Do y'all see what I'm asking you to do? Yes. Is that a little bit easier than going down at the bottom and having to create a number line and having to estimate and all that jazz? I'm not in that business. I want it to be as easy as possible. If you can, even if it doesn't look this pretty, if you can tell me these numbers, I know you know what you're doing. I can figure the rest of it out. Y'all with me? All right. So let's keep moving. We got 2 more examples to look at, because now we're going to look at problems where I give you a box and whisker and you've got to compare it to another one. Okay? So this one shows a box and whisker plot for numbers of mugs sold by students in 2 different grades. So up top, you've got 8th grade, and on the bottom, you've got 7th grade, okay? Here, you've just got to be able to look at it, understand the numbers, and then see what the question is asking you, okay? So, in question A, it says about how much greater was the median number in the middle, okay, of mugs sold by 8th grade to the number of mugs sold by 7th grade. Well, here's where you're going to have to do, and you're going to have some number sense here, okay? You're going to estimate. So, that means you've got to find the median for both 8th grade and 7th grade. Here's how you're going to do it. You're going to look at your box and whisker, and you're just going to try and continue down that median and see where it lands, okay? So, for 7th grade, I colored it in that red line, and it goes straight down. Well, I can look at my number scale, and I know, hey, well, it goes from 30, there's a hash, and then 40. Well, that means each tick mark is worth how many? 5. Don't overstress this. If I give you one like this, there'll be some room for error, okay? So when I look at this, I'd say, okay, well, it's not quite 35, but it's pretty close. So I'd say the median for 7th grade was what? 34. Okay? And then I'm going to do the same thing for 8th grade. It's just going to be slightly harder, okay? And I'm going to try and stay as straight as possible because it's a little bit higher. Okay, well, looking at that, well, I'd say I know I probably lost it a little bit, but for me, that's pretty close to what number? 40. So the 8th grade median was 40. Well, to find what the difference in those is, what do you think you're going to do? Subtract. 40 minus 34 would be 6. So the difference in the median number is about 6. Now, the next thing, I can draw lines if I want to, but it's also one where you can look at it and kind of have a common sense. Isn't that right? So, when you look at it, they want to know which data set has the greatest maximum. 8th grade, that's 100%. So the reason here, you would say, hey, well, the greatest maximum is going to be 8th grade. And then when it asks why, all you've got to say is it has the higher number in its data set. And how you can tell that, for anybody who might have been lost, is we just looked and we saw that 8th grade's highest number was further along the number line, further out than 7th grade. Okay? All right, last slide. We're almost done. Okay, almost done, and then you're going to have all next period to work on your homework here. Okay? So again, it says use the box and whisker plot to answer each question. Here, it wants to know which data set has the smaller range. Okay? What you have to think of here, how do you find range? The biggest number minus the smallest number, 100%. So that means you're going to have to do this twice. So I'm going to start with the year 2000. Okay? Well, what was the biggest number in year 2000? Well, I come over here and I'm going to drop that down. Well, it's a little bigger than 250. Okay? Here's what you got to know. As you look at this, all right, each of these goes up by how many? 25 each time. So as I'm looking at that, it's a little bit bigger than 250, but it's not quite 275. My guess is 260. Okay? There's room for error. As long as we're close, you'll be all right. Now, when I look at the smaller number, I'm going to come over here to this end, and I'm going to drag it straight down and try and be as straight as possible. Okay? Now, as I look at it, okay, well, it's not quite a 100, but it's pretty close. I'm going to say that's probably about 10 off, so I'm going to estimate it is 90. So to find the range of the year 2000, you just take 260 and subtract 90, which gives you what? 170. Okay? Then you've got to come do the exact same thing we just did for the year 2007. Okay? Well, let's start with the maximum. Okay? It's this number out here. All right. Well, it's bigger than 325, but it's not quite to 350. I'm going to say that's probably 335. And then as I come back and look at its smallest value, well, the same thing right here. It's bigger than 100, not quite 125, but I'd say that's pretty close to 125, so I'm going to guess it's 120. So then I'm going to go 335 minus 120, and I get out what? 215. Now, I've got my two ranges. Let me just re-look at the question. It says, which data set has the smaller range? Yeah, 2000. So you would just say here it is the year 2000. And they ask why, you would say the space between the biggest and smallest number is smaller. Okay. All right, and then just trying to finish before the bell right here about how much more was the median ticket for sales for the top 25 movies in 2007 than in 2000. So that's just looking here again at the medians. So if you drop that one straight down, I'd say that's pretty close to being 125. And then if you look at the median for here, ooh, well, it's not quite 175, so I'd say it's probably 170. So you would just have to go 170 minus 125. And what would you get out? 45. Bam. All right. So that is a box and whisker. So that's being able to create it on our own and look at them and get information. Again, the key is knowing those 5 numbers, what they represent, and how to draw it. Okay. So in a few minutes, we will get started on our homework for today. Ready, set, go.